Welcome to Angles of Elevation and Depression. Fun fact, I'm afraid of heights.
First thing we're talking about is an angle of elevation. So the angle of elevation is the angle formed by a horizontal line and the line of sight to an object above the horizontal line. So if you take a look at our example down here, you can see how this works. We start with our observer, and from our observer, we're going to draw a horizontal line coming from the observer's eyes, and we're going to draw another line that connects the observer's eyes to what they're looking at, which in this case would be this plane up here. That would be called the line of sight. Now the angle formed by that horizontal line and the line of sight above that horizontal line will be called your angle of elevation. Next, let's talk about the angle of depression. So the angle of depression is the angle formed by a horizontal line and the line of sight to an object below the horizontal line. So in this particular example, we have an observer above an object that he is looking at. Now, to create the angle of depression, what you're going to do is draw a horizontal line coming from our observer's eyes and then draw a line connecting the observer's eyes to the object they are looking at. That is called your line of sight. Now, the angle formed by that horizontal line and your line of sight below the horizontal line would be called the angle of depression. Now, it's important to note that an angle of elevation or depression doesn't have to start at a person's eyes. It could start at an object. It could start at a building. It could start wherever you want to draw your horizontal line, because an angle of elevation or depression just needs a horizontal line and then a line either above or below that horizontal line.
It's example time. Where the hell is Robin? He's supposed to be doing these.
Now, example 1 says describe the angles given in the picture as angles of elevation or depression. In part A, we're looking at angle 6. So angle 6, we have a horizontal line and we have a line of sight below that horizontal line. Because of that, angle 6 must be an angle of depression. Part B, we're looking at angle 7. Angle 7 would be right here. This time we are coming from our observer's eyes over here. So from our observer's eyes, we have this horizontal line, and then the line of sight would be above that horizontal line. Because we have a line of sight above the horizontal line, it's going to create an angle of elevation. Part C, we're looking at angle 8 right here. This time again, we are coming from our observer's eyes over here. We draw our horizontal line going this way, and we have a line of sight below that horizontal line. Because our line of sight is below the horizontal line this time, angle 8 would be considered an angle of depression. Now, angle 9 down here, we have a horizontal line coming from our statue's feet, and the line of sight goes from the statue's feet to our observer's eyes up here. Because our line of sight is above our horizontal line this time, we can say that angle 9 must be an angle of elevation. Now, example 2 says find the value of x, round lengths to the nearest tenth. So in this figure over here, we are given a horizontal line that connects to the upper vertex up here of our right triangle. Now, because we have a horizontal line and a line of sight below that horizontal line, we can consider this 40 degrees right here an angle of depression. Now, how does that help us? Well, what we can do is solve for the angle measure adjacent to that angle of depression. How do we do that? Well, these two lines are parallel to one another, making this side of our triangle a transversal. So these two angles, this whole angle up here and this angle down here, would actually be considered consecutive interior angles, meaning that they must be supplementary. So if this angle is 90 degrees, we can subtract that from 180 and we're left with 90 degrees, meaning this whole angle up here must be 90 degrees. So if this angle right here is 40 degrees, we can subtract that from 90 and we're left with a measure of this angle in our right triangle as 50 degrees. So again, how does that help us? Well, we are given a right triangle. We are given one of the acute angle measures of our right triangle. We're given one of the legs of our right triangle, and we're trying to find the length of the hypotenuse. So we clearly need to set up a trig ratio in order to solve for x. So how do we set up this trig ratio? Coming from the acute angle measure that we're given, we are also given the length of the leg adjacent to that given angle, and we are trying to find the length of the hypotenuse. So which trig ratio deals with adjacent over hypotenuse? That would be cosine. So we're going to go cosine of our angle is going to be equal to the length of the leg adjacent to that angle over the length of the hypotenuse, the side opposite our 90-degree angle. So now all we have to do is solve for x. So how do we solve this trig ratio over here for x? Well, we got to get it out of the denominator. So how do you get x out of the denominator? You need to multiply both sides of the equation by x. That will get it out of the denominator. Now all you have to do to get x by itself is divide both sides by cosine of 50. You can then plug this in your calculator. Make sure your calculator is in degree mode and not radian mode, otherwise you'll get the wrong answer, and you end up getting that x is approximately equal to 777.9 meters. Remember, we're rounding to the nearest tenth of a meter.
Don't let this be your bane. You try.
Okay, doing the same thing here. We are again given a right triangle and we have a horizontal line coming from our vertex up here. We know this angle right here is formed by a horizontal line and a line of sight below that horizontal line, making 25 degrees an angle of depression up here. Now we can use that angle of depression in order to find the acute angle measure of our right triangle up here, because if these two lines are parallel to one another, this angle right here and this angle right here must be consecutive interior angles, or same side interior angles, meaning they must be supplementary. So if this angle is 90 degrees, this angle up here must also be 90 degrees. So I just take 90 degrees, subtract 25 degrees, and I'm left with the measure of our acute angle up here of our right triangle as 65 degrees. Now the question is, what are we solving for? There's no variable here. Well, we are finding the missing side lengths of this right triangle. So we need to find the lengths of both of these legs. So it doesn't matter which one you solve for first. I'm going to pick this one. So I'll give it a variable. We'll call it x. So now in this right triangle, I have one of the acute angle measures. I am given the length of the hypotenuse, the side opposite our 90-degree angle, and I'm trying to find one of the legs. So clearly, in order to find the length of this leg right here, I need to set up a trig ratio. So coming from the acute angle that we are given, we are trying to find the length of the leg opposite that angle, and we're given the length of the hypotenuse, the length of the side opposite our 90-degree angle. So what trig ratio deals with opposite over hypotenuse? That would be sine. So we're going to go sine of our angle, 65 degrees, is equal to opposite x over hypotenuse, 23.5. Now all we have to do is solve for x. So to get x by itself, I multiply both sides by 23.5, and I plug this in my calculator, making sure my calculator is in degree mode and not radian mode. When I press enter, I get that x is approximately equal to 21.3 feet because I'm rounding to the nearest 10. Now we're only halfway done. We have found one of the legs of our right triangle. We need to find the other missing leg. So if we call this leg x, we'll call the measure of this leg over here y. Now we need to set up another trig ratio in order to solve for y. So coming from the measure of our acute angle that we were given up here, we are trying to find the length of the leg adjacent to that angle, which would be this y right here. And we are given the length of the hypotenuse, the side opposite our 90-degree angle. Now what trig ratio involves adjacent over hypotenuse? That would be cosine. So we're going to go cosine of 65 degrees is equal to y over 23.5, adjacent over hypotenuse. Now, in order to solve for y, all you have to do is multiply both sides of the equation by 23.5, plug this into your calculator, make sure your calculator is in degree mode, not radian mode, and you get that y is approximately 9.9 feet. Now, one of the most common mistakes in this type of problem is solving for the measure of this leg, like we did, rounding it like we're supposed to, and then using that rounded side length in order to figure out our other side length. If you use a rounded side length too early in a problem, it will make your other answer more incorrect. So please make sure you're using the exact measurements that you're given. Use the 65 degrees, use the 23.5 feet, because we know those are exact. This side length is approximately 21.3 feet. So if you use that measurement, your other answer for y is going to be a little less correct than it should be. If you needed to use this side length for some reason, just make sure you use the entire decimal. Don't use the rounded version. Part B, doing the same thing. We again have a horizontal line connected to this vertex up here in our right triangle. We then look at our hypotenuse as a line of sight below that horizontal line, making this 72 degrees right here an angle of depression. Now, don't get carried away. This is clearly not 72 degrees. We'll just say our figure right here is not drawn to scale. So how do we figure out the measures of our missing side lengths over here? Well, we need to set up a trig ratio. In order to do that, we first need to figure out the measures of one of our acute angles up here. Well, we know that these two lines are parallel, cut by our transversal, which is the side length right here, meaning that this angle up here, this whole angle, and this angle down here must be consecutive interior angles, making them supplementary. So we could say that since this is 90 degrees, this whole angle up here must be 90 degrees. So we can find the measure of this missing acute angle by taking 72 degrees, subtracting it from 90 degrees, and we're left with 18 degrees. Now we can use the measure of this acute angle that we're given in the right triangle and this one side length to find our other two missing side lengths. So which side length do we want to find first? Doesn't matter. Let's find this side length down here. We'll call it x. In order to find this missing side length, we're going to set up a trig ratio to solve for x. So coming from our given acute angle up here, we are trying to find the length of the leg opposite that angle, and we are given the length of the leg adjacent to that angle. So what trig ratio uses opposite over adjacent? That would be tangent. So we're going to go tangent of our angle, 18 degrees, is equal to x over 23.1. 32.1. Now we just need to solve for x. So how do we solve for x? We multiply both sides by 32.1, plug this in our calculator, and we get that x is approximately equal to 10.4 centimeters when we round to the nearest tenth. So we're going to plug that in over here. Now we're not done. We need to find all of the missing side lengths. So we also need to find the length of our hypotenuse here. We'll call that y. So how do we find y? Well, we need to set up another trig ratio to solve for y. And what we talked about last time is that we want to use our exact measurements. We want to use this 18 degrees and we want to use this 32.1 centimeters. We don't want to use this 10.4 centimeters if we don't have to because it's rounded, which will make this more incorrect than it needs to be. So again, we need to set up a trig ratio coming from our given acute angle measure. We are also given the leg adjacent to that angle, and we are trying to find this time the hypotenuse, the side opposite our 90-degree angle. So what trig ratio involves adjacent over hypotenuse? That would be cosine. So we're going to go cosine of our given angle, 18 degrees, is equal to the length of the leg adjacent to that angle, which would be 32.1 centimeters, over the length of the hypotenuse, which is y. Now in this case, it's a little bit more complicated to solve for than it was up here because y is in our denominator. To get it out, what we have to do is multiply both sides of the equation by y. And when we do that, our y is now out of the denominator, and we can get it all by itself by just dividing both sides by cosine of 18. Now when you plug this into your calculator, you'll get the length of our hypotenuse here, which is approximately equal to 33.8 centimeters when we round to the nearest tenth. Now example 3 says determine the angle of depression using the figure below. Round your answer to the nearest tenth of a degree. So in this particular example, we're given two of the legs of our right triangle, and we are tasked with finding the angle of depression right here. So we'll just give it a variable right now. We'll call it d. Now the question is, how do we find the measure of d here? Well, if we know that these two lines are parallel, and we look at this leg of our triangle as a transversal, then these two angles, this angle right here and this whole angle up here, must be consecutive interior angles, meaning they must be supplementary. So if the measure of this angle down here is 90 degrees, the measure of this angle up here must also be 90 degrees. So all I have to do to figure out the measure of angle D here is just find the measure of this little acute angle in our triangle. We'll call it A for right now. And then I could just subtract that from 90, and that will give me the measure of D here. So that's what we're going to do. We need to find the measure of A here. Well, how do we find the measure of A? Well, again, we have a right triangle. We're trying to find one of the acute angle measures of our right triangle, and we're given the lengths of two of the legs. So we need to set up a trig ratio in order to solve for our A here. Well, what trig ratio we're going to use? Sine, cosine, or tangent? Well, coming from this angle that we're trying to find, we are given the length of the leg opposite that angle and the length of the leg adjacent to that angle. So which trig ratio uses opposite over adjacent? That would be tangent. So we're going to say tangent of our angle A is equal to the length of the leg opposite that angle, 221 miles, over the length of the leg adjacent to that angle, which is 184 miles. Now all we have to do is solve for A. Well, how do we solve this for A again? I need to get rid of the tangent. To get rid of sine, cosine, or tangent, you need to take the inverse sine, inverse cosine, or inverse tangent of both sides. Here, since we're taking tangent of A and I want to get rid of tangent, I take the inverse tangent of both sides of the equation. The reason I do that is because the inverse tangent of tangent, those two things cancel each other out and just leave us with A. Now all I have to do to find the measure of A is just plug this in my calculator. Take the inverse tangent of 221 over 184, press enter, and I get that A is approximately equal to 50.219939 degrees. Now notice how I didn't round this too early. That's because this is not my answer. I'm trying to find the measure of D here, the angle of depression. And if you recall, the measure of D is just going to be equal to 90 degrees minus the measure of this angle A right here. So what I'm going to do is take 90 degrees, subtract my entire decimal for my angle A, and then I can round and say that D has to approximately be equal to 39.8 degrees.
I know Robin's trying. Are you trying? You try.
Okay, doing the same thing here, except this time I'm looking for the angle of elevation. So the angle of elevation, remember, we have a horizontal line here coming from our vertex, and then our line of sight above that horizontal line create the angle of elevation here, which we can call E. Now, in order to find E, if you remember what we just did in the previous example, we're going to look at these two parallel lines and look at this side of our triangle as the transversal. So if we have two parallel lines cut by transversal, these would be consecutive interior angles, meaning that they must must be supplementary. So if this angle up here is 90 degrees, this entire angle down here must be 90 degrees. So if I want to find the measure of angle E, all I have to do is find the measure of this acute angle in our triangle. We'll call it X. And then I can take the measure of this angle, subtract it from 90 degrees, and it'll give me the measure of our angle of elevation. So how do we find the measure of this acute angle right here? Well, again, if you're trying to find the measure of an acute angle in your right triangle and you're given two side lengths, you can just set up a trig ratio. So which one are we going to use? Sine, cosine, or tangent? Well, coming from the angle that we are trying to find, we are given the length of the leg adjacent to that angle, and we're given the length of the side opposite the 90-degree angle, meaning we're given the length of our hypotenuse. So which trig ratio uses adjacent over hypotenuse? That would be cosine. So we're going to say cosine of our angle down here, X, is equal to the length of the leg adjacent to that, 17 kilometers, over the length of our hypotenuse, 24 kilometers. Now all we have to do to solve for X is get rid of this cosine. So how do we get rid of the cosine? Well, if you want to get rid of a trig function, all you have to do is take the inverse trig function of both sides. So in this case, we have cosine we want to get rid of. We're going to take the inverse cosine of both sides. Now the inverse cosine of cosine, those two things cancel each other out. That's why we did it. And we're left with X is equal to the inverse cosine of 17 over 24. So to get the measure of our angle X down here, all we have to do is plug this in our calculator, and we get that X is approximately equal to 44.900527996 degrees. Now again, I did not round this because X is not what we're looking for. We're looking for the angle of elevation here, E. So we're going to take as exact a measure for angle X as we can, and we're going to subtract that from 90 degrees in order to find the measure of our angle of elevation here. And we get that E is going to be approximately equal to 45.1 degrees. And that would be the angle of elevation, meaning we can round it to the nearest tenth of a degree. Now example 4 says a blimp is providing aerial television views of a baseball game. The television camera sights the stadium at a 7-degree angle of depression. The blimp's altitude is 482 meters. What is the line of sight distance from the TV camera to the stadium to the nearest hundredth of a meter? Now in order to answer this question, we clearly need to make a sketch here. So we have our blimp that has a TV camera that is pointed at our given stadium, creating a line of sight. We know that the television camera sights the stadium at a 7-degree angle of depression. So to create an angle of depression, we're going to draw a horizontal line coming from our camera up here that is parallel to the ground. Then our line of sight is below that horizontal line, creating our 7-degree angle of depression. We also know that the blimp's altitude is 482 meters. So we can draw a perpendicular line from the blimp to the ground that measures 482 meters. So we've made our sketch. Now we just have to figure out what is the question asking us to find. Well, it says, what is the line of sight distance from the TV camera to the stadium? So we need to figure out the line of sight distance. So this measure right here, we'll call it X. How in the world am I going to figure out this length right here? We just do what we were doing. We're going to eventually set up a trig ratio with this right triangle to solve for X. The only issue is we don't have either of the measures of the acute angles in this right triangle. Was there any way we could figure those out? Yeah, we can figure out this one right here because we know that these two lines right here are parallel. And if we look at the height here as our transversal, we know that these two angles in here must be consecutive interior angles, meaning they must be supplementary. So if this angle down here is 90 degrees, this whole angle up here must also be 90 degrees. So I just take 90 degrees, subtract 7 degrees, and I'm left with 83 degrees. Now I have the measure of this acute angle, so I can create that trig ratio in order to solve for X. So how do I do this? Well, coming from the angle that we are given, we are also given the length of the leg adjacent to that given angle, and we're given the length of the side opposite our 90-degree angle. We're given the length of our hypotenuse. So what trig ratio involves adjacent over hypotenuse? That would be cosine. So we say cosine of our angle, 83 degrees, is equal to the length of the leg adjacent to that, 482 meters, over the length of the hypotenuse, which we're trying to find. We'll call it X. Now, to solve for X, what we need to do is get X out of the denominator. So how do we get X out of the denominator? We have to multiply both sides of the equation by X. The reason we do that is because now X is out of the denominator. And all we have to do to get X by itself to solve for X is divide both sides by the cosine of 83 degrees. We then plug this in our calculator and we get that X is approximately equal to 3,955.06 meters if we're rounding to the nearest hundredth of a meter. So make sure you answer in a sentence. What is the line of sight distance from the TV camera to the stadium? Well, the line of sight distance from the camera to the stadium is approximately 3,955.06 meters.
I founded the Justice League, and I'm basically just a rich guy. You try.
Okay, this says 2 office buildings are 50 feet apart. The height of the taller building is 258 feet. The angle of depression from the top of the taller building to the top of the shorter building is 15 degrees. Find the height of the shorter building to the nearest foot. So again, the first thing we should do in this question is label our sketch down here. We have our taller building and we have our shorter building. And we know the 2 office buildings are 50 feet apart. We also know that the height of the taller building is 258 feet. And we know that the angle of depression from the top of the taller building to the top of the shorter building is 15 degrees. So how do we draw that? Well, we create a horizontal line coming from the top of the taller building and the line of sight going down from the top of the taller building to the top of the shorter building. And that angle measure in here is going to be 15 degrees. That's our angle of depression. Now, what is the question asking us to find? It's asking us to find the height of the shorter building to the nearest foot. So we'll label that with our variable here. We'll call that B. Now, in order to find B, the height of our shorter building, what we're going to have to do is take the height of our taller building, 258 feet, and just subtract out the difference between the 2 heights. This distance right here, we'll call that X. Now the question is, how do we find X? Well, as you see, we've created this right triangle here, where we know the length of one leg of our right triangle, and we're trying to find the length of the other leg. Well, we could solve for that if we knew one of the acute angle measures here, but we don't. Well, is there a way we could find one of the acute angle measures here? Yeah, if we know that these 2 lines are parallel, and we take X right here as our transversal, then we know that this angle right here and this whole angle up here would be consecutive interior angles, meaning that they must be supplementary with each other. Meaning that if this angle right here is 90 degrees, this whole angle up here must also be 90 degrees. So if I want to find the measure of this acute angle in our triangle, what I have to do is just take 90 degrees, subtract 15 degrees, our angle of depression, and I'm left with 75 degrees. Now I can set up a trig ratio in order to find X. So which trig ratio am I going to use? Sine, cosine, or tangent? Well, I'm given this angle right here, 75 degrees, and I'm also given the length of the leg opposite that angle. I'm trying to find the length of the leg adjacent to that angle. So which trig ratio involves opposite over adjacent? That would be tangent. So I'm going to say tangent of my angle, 75 degrees, is equal to the length of the leg opposite that, 50 feet, over the length of the leg adjacent to that, which we're calling X feet. Now all I have to do is solve for X. Ooh, I got X in my denominator. Remember, to get X out of the denominator, you just multiply both sides of the equation by X. When I do that, the X's over here cancel out. On this side, I then have X times tangent of 75 degrees. So to get X all by itself, I just divide both sides by tangent of 75 degrees. I then plug this in my calculator, and I get that X is approximately equal to 13.39746 feet. Now notice, I did not round this to the nearest foot because the problem does not want you to find X. It wants you to find the height of the shorter building, which we know is B. And we said in order to find the height of the shorter building, what we have to do is take the height of the taller building and subtract out the difference, which we found to be X. So let's find the height of the shorter building, B. To find B, we just said we take the height of the taller building, 258 feet, subtract out the difference between the 2 heights, which we found to be X, and then we get that B is approximately equal to 245 feet. Notice there's no decimal here because we are rounding to the nearest foot. Now remember, we were asked a question. The question was, find the height of the shorter building. So please answer in a sentence. The height of the shorter building is approximately 245 feet, or the shorter building is approximately 245 feet tall.